Alright, in this video we will look at the expectation or mean and variance of the binomial random variable. Recall that if x is a binomial random variable with parameters n and p, then its PMF is given by p of k equal to n choose k p to the k times 1 minus p to the n minus k. The expectation of x, or the mean of x, is given by n times p. That is, you multiply the parameters of x, and the variance of x is given by np times 1 minus p. The CDF of x is given by f of I is equal to the probability that x is less than or equal to I, which is the same as the sum of p of k, where k is less than or equal to I. So the CDF function f evaluated at I is equal to the summation k going from 0 to I, n choose k p to the k 1 minus p to the n minus k. And we also have this recursive formula, p of k plus 1 is equal to p over 1 minus p n minus k over k plus 1 times p of k. This is called the recursive formula. The reason is if I know the value of p of 1, then I can calculate the value of p of 2 from this formula. If I know p of 2, then I can find p of 3 from this formula. If I know p of 3, then I can find the p of 4 from this formula, and so on. So this is why it's called a recursive formula. Now I'm not going to derive 2, 3, or 5. I'm not going to derive 3 or 5. I'm going to derive 2 for you. So let's derive the expectation or mean of x. By definition, the expectation of x is the summation k going from 0 to n k times p of k, right? So you multiply each value of x by its probability and you add them. Now this is equal to, since when k is 0, we get we get a zero term, right? The first term of this sum is 0. So let's get rid of that and start the sum at once. So k going from 1 to n, k times p of k. Okay, so now I'm going to plug in p of k. So this is k going from 1 up to n, k times n choose k p to the k 1 minus p to the n minus k. And we are going to rewrite this in terms of factorials. So n choose k is n factorial, k factorial, n minus k factorial, p to the k 1 minus p to the n minus k. So then I will further rewrite that as k going from 1 up to n, k, n factorial can be written as n times n minus 1 factorial. K factorial is k times k minus 1 factorial. And then I have n minus k factorial, p to the k 1 minus p to the n minus k. Now I am going to do the following. K cancels out. I am going to factor out n from the sum, and I'm also going to factor out p. So if I do that, what I get is k going from 1 up to n, n minus 1 factorial over k minus 1 factorial, n minus k factorial, p to the k minus 1, because I factored out a p, and then I have 1 minus p to the n minus k. Now what you have to realize is that I have np summation k going from 1 up to n. This quantity here, that quantity is the same as n minus 1 choose you know what, before I do that, let's do the following. Let's change the index of the sum again. So what I'm going to do is replace k by k plus 1. In that case, I'm going to get n minus 1 factorial. If I replace k by k plus 1, I'm going to get a k factorial and n minus k minus 1 factorial here. P to the k, because I'm replacing k by k plus 1, 1 minus p to the n minus k minus 1. And here the index will go from 0 to n minus 1. Okay, so we change the index. Let me make some room here. Okay, so then notice what we have now. np summation k going from 0 to n minus 1. n minus 1 choose k, p to the k times 1 minus p to the n minus 1 minus k. Okay, now notice that this is the sum of this is the total probability when we have n minus 1 trials. So so this is basically np times the summation k going from 0 to n minus 1, and this is the probability, of getting exactly k successes in n minus 1 trials. So basically it means that if you take a binomial random variable where you have n minus 1 trials, then this sum is the total probability of that variable, so this sum is going to be 1. And so therefore what we have obtained is that the expectation of x is np. Alright, so I hope that you understood the derivation of this of the mean of x. So if you want, you can go ahead and look at the derivation of the variance of x from the book, or try it yourself and see if you can do that yourself. In the next video we will go over an example.